Okay, so let's practice with synthetic division, determining whether the binomial that's provided is a factor of the polynomial. So, for example, on number 7, the factor that we've been given is x minus 3. So when we're doing synthetic division, we will use that to make our 0. And then the polynomial we're checking on is x squared plus 2x minus 3. So our coefficients are going to be 1, 2, and negative 3. All right, so bring down the 1. Multiply. 1 times 3 is 3. Add those up, we get 5. 3 times 5 is 15. It's not looking good for this one being a factor because these don't add up to 0, they add up to 12. So that means x minus 3 is not a factor. Easy. Alright, so I'm going to say pause here and have you try B on your own. So really give it like 30 seconds. Try with your table. See if you guys can do this. See if it's a factor. And then check back here. I'll show you all how to do it. Okay, so hopefully you took a second to try this one on your own. When we look at our factor, x plus 4, that makes our 0 negative 4. And so that's what we're going to put in the corner. And then this one, you do have to be careful on those coefficients. So we've got 2x to the fourths. We've got 8x cubes. If you notice, there are 0x squared. So if you miss that, it might have messed you up a little bit. So 2, 8, 0. And then we have 2x squared and then 8 here. Alright, so now let's check our work. Bring down the 2. Let's go ahead and multiply. Negative 4 times 2 is negative 8. These add up to 0. Negative 4 times 0, well, anything times 0 is 0. Add those up, we're 0 again. Negative 4 times 0 gets us 0 again. 2 plus 0 finally gets us something other than 0. Then I take that 2 times negative 4 and I get negative 8. And this is looking good because 8 plus negative 8 add up to 0. So we would say yes, x plus 4 is a factor. And that also means that x equals negative 4 is a 0. Right? So thinking about what we've been doing with our polynomial graphs, that means negative 4 is a place where the graph touches the x-axis if we were going to graph this function out. And then let's just take our coefficients here and let's turn them into a polynomial. So let's take those coefficients and rewrite them. And remember that whatever degree we started with, 2x to the fourth, when we do a round of synthetic division, we drop by 1 degree. So this 2 then represents how many x cubes we have. We have no x squareds, no x's, and then this last one is always just a constant, a number without the variable. And so this would be our quotient here, if we're looking to represent that. If you want to go back to the one we just did and write that, it's good practice. So the 1 and the 5 is going to represent a constant. The 1 is going to represent x's. So we have x plus 5. And then remember, our remainder, 12, goes over our divisor. Now, a common mistake here is people just take the number from here and put it in our divisor. But that's not what we're supposed to do. What we divided by was x minus 3. We used this shortcut, synthetic division, but the divisor was x minus 3. Okay, so we're going to put this all together so we can start using synthetic division and taking 1 or 2 factors and then getting all of the factors of our polynomial and eventually all of the zeros. So show that x plus 3 is a factor of this cubic polynomial and then find the remaining factors. Alright, so let's do our synthetic division, and because x plus 3 is our factor, negative 3 goes in the corner. And then let's check our coefficients. We have 1x cubed. There are no x squareds, so put in a 0. There are negative 19x's, and then negative 30. Alright, so bring down the 1, do the multiplication. Again, we're adding. So 0 plus negative 3 is negative 3. Multiply that times negative 3, we get 9. Add those up, we get negative 10. Multiply those, we get positive 30. Okay, so it said show that it's a factor, so we expected to get 0 for our remainder. Now this 1, -3, and -10 represent coefficients of a quadratic, because we just did one round of division from a cubic. X squared minus 3x minus 10. All right, so let's just take this x plus 3. I'm going to write the whole function. F of x equals, and we were told x plus 3 was a factor, so we knew that. Now we're going to take this x squared minus 3x minus 10, and let's go ahead and factor that if we can. So remember, we start with x's to get our x squared, and we're looking for things that multiply to -10, but add up to -3. So we know we're going to deal with 5 and 2. And then in order to add up to -3, we need -5 and +2. So I can add those factors now. X minus 5, x plus 2. Awesome. So we have fully factored this polynomial. We have all three factors. And thinking back to what we did last time, if you know these factors, you should be able to sketch a graph. Because you know the 3 zeros, you should be able to identify the end behavior. So that's kind of what we're working towards, is being able to take these larger polynomials and a couple factors and figure out all of them so we could graph it. Okay, so let's take a look at number 9. Here we've got a quartic, a degree 4 function. And we're going to verify that x plus 2 and x minus 4 are factors. And then we'll use our results to get a full factorization of the function and identify the zeros. So let's go ahead and get started. It doesn't matter which factor I start with. So I'm going to say x plus 2, that means my 0 is going to be -2. And then let's take our coefficients 8, -14, -71, -10, and 24. All right, bring down the 8, and here we go. -2 times 8, -16. When we add these two negative numbers, we get a negative number, -30. Multiply two negative numbers, we get a positive, so +60. Then we're going to add these two, -11. -2 times -11 is +22. We're going to add -10 and 22, we get 12. And then -2 times 12 is -24. Now, if we are told to verify that something is a factor, then we should expect to see 0 as our remainder. And if you get something else, you might want to go back and check your work. Okay, so as we're looking, we've got f of x equals, and we just verified that x plus 2 is absolutely a factor. Let's do it again with x minus 4. So I'm going to take the coefficients that we have from our first round, and I'm just going to set up another problem. If x minus 4 is my factor, then 4 is my 0. And just bring down the 8. So 4 times 8 is 32. Add these up, we get +2. 4 times 2 is 8. When we add -11 and 8, we get -3. 4 times -3 is -12. And 0 is what we get for our remainder. Okay, so yes, we were supposed to get 0 because we said we know that's a factor, we're just verifying it. Alright, so I can confirm that x plus 2 and x minus 4 are factors. And what we're left with now are these three coefficients. Right, so that's going to represent the coefficients for a quadratic. We've got 8x squared plus 2x minus 3. And what we're trying to do is figure out, all right, we want to factor that. And this one can be a little challenging because for 8x squared, we have a couple different ways we could break that down. 8x and 1x, or 4x and 2x. Let's just try 4x and 2x to start. And then the only things that multiply to -3 are -3 and +1, or -1 and +3. So we're just trying to figure out how do we end up with only 2 x's when we add them up. So I have to place the 1 and the 3 somewhere strategically. So I'm going to go ahead and put the 1 over here and the 3 here. And the reason is when I do my outer terms, I'm going to get 4x, and my inner terms, I'm going to get 6x. So let's do this. This one would be 6x. This one would be 4x. If I want to get those to add up to +2, then I need a positive for the 6x and a negative for the 4x. The way we accomplish that is with a minus sign here and a plus sign here. Alright, so we are factored, and then I've got 4x plus 3 as one factor and 2x minus 1 as another. All right, so now that we have this fully factored, we could just go ahead and identify all of the zeros, right? So if I wanted to identify the zeros, x plus 2 as a factor gives us negative 2. X minus 4 gives us positive 4. And if you're not so sure on each of these, just take a quick second, set them equal to 0, right? So I'm just going to take each one and say, all right, 4x plus 3 equals 0. That means I would subtract the 3 over and then divide by 4. So then I'd say, okay, we've got negative 3/4 for this one. And then for the 2x minus 1, same thing, 2x minus 1 equals 0. We'd add the 1 over and then divide by 2. And so we get 1/2. All right, so we've got all 4 zeros. You could sketch this graph now with everything that you know. All right, the last thing we're going to take a look at are these two problems. It's another application for synthetic division, or kind of another way of thinking about it. And it says, consider the function p of x equals x to the 4th minus 2x cubed plus 3x squared minus 2x plus 1. Find p of 2 without a calculator. So let's go ahead and say, if we're finding p of 2, that means we're plugging in 2 for x. So let's say, all right, p of 2 equals, and then I would do 2 to the 4th minus 2, and then that would be 2 cubed, because I'm just plugging in for each of these x's, plus 3, 2 squared, minus 2 times 2, plus 1. All right, so we just have to do some arithmetic. So 2 to the 4th is 16. 2 cubed is 8, and then we multiply by this negative 2, so minus 16. 2 squared is 4. Always do the power first, then multiply by the number out front. So 4 times 3 is 12. And then negative 2 times 2 is negative 4 plus 1. All right, the 16 zero out. And then we've got 12 minus 4 plus 1. So that's 8 plus 1 is 9. So we can say p of 2 equals 9. All right, the next question asks us about the same polynomial to determine if x minus 2 is a factor. So x minus 2, we would put in the corner here as our 0. We would use the 0 from that, we get 2. And then we're just going to see if it's a factor. If it is, remember what we're supposed to get as our remainder. We're supposed to get 1. So I'm going to do 1 for x to the 4th minus 2x cubed, 3x squared minus 2x's, and then plus 1. All right, so let's do our synthetic division. 2 times 1 is 2, get 0. 2 times 0 is 0. Add these up and we get 3. 2 times 3 is 6. Add those up and we get 4. 2 times 4 is 8. And 8 plus 1 is 9. All right, so when you look at this, there's a reason why we chose these problems. It says, what do you notice about this? So when I look at my first one, p of 2 equaled 9. And when I look at my remainder on this one, my remainder is 9. And so we can say that synthetic division helps us quickly plug a number in. Whatever we put in for that 0, like whatever goes right here, is what we're plugging in. And then whatever goes right here is what we're getting out. And so it's a quick way to plug a number in instead of doing the math where you're raising things to a power and everything. We can sort of say generally then, p of k, right, and that's whatever we plugged in here. So in this case, that k was 2, equals our remainder. And if there is no remainder, then we know it's a factor. Or we can say if there is no remainder, then we know that number that we plugged in is a 0. So keep that in mind for today's Delta Math practice. Make sure you go access it, not from Delta Math, but from Blend. And good luck with everything. Work together on the Delta Math with your table mate.